Hello and welcome to another calculus video. Today we're going to be talking about the chain rule. Now this is again another big topic in calculus. This is something that gave me a lot of trouble the first time I had to deal with it, but it's going to make a lot of things so much easier, and it's going to open the door for us to differentiate nearly any function that we'll encounter. So let's talk about the chain rule. This is also the third part of our differentiation rules, but this gets its own video because it's so big. Okay, this is the definition of our chain rule. So we're going to use the chain rule whenever we have to differentiate a composite function, which means some function that can be written as f of g of x. And so this is going to be our formula. We have our outside, I'm going to call f our outside function and g our inside function. So the derivative of f of g of x is f prime of g of x times g prime of x. So what this means is we're going to find whatever f prime is, and instead of plugging in x, we're going to plug in whatever g of x is. And then we're going to multiply by whatever g prime of x is. So this will probably be a lot clearer when we go over some examples, but first let's look at the steps that we're going to use. The first thing we're going to do is we're going to determine f of x and g of x that we know the derivative of so that we can really easily figure that out. Then we're going to find f prime of x and g prime of x, and then we're going to just plug it into our formula. Okay, so let's find the derivative of x plus 2 squared. Now, to start off, just to prove to you that this is a real thing, I'm going to first multiply x plus 2 squared. I'm going to FOIL it out just to prove that the derivative is equal no matter what method you use. So if you FOIL this out, you'll get x squared plus 4x plus 4. If I differentiate that, I get 2x plus 4, and so that would be our answer. But now we're going to do it using the chain rule. So our outside function, as you can see, is going to be x squared. And our inside function is just going to be x plus 2. So just take a moment to convince yourself that f of g of x really is equal to this. Okay. Now we're going to find the derivative of each of these functions. So f prime of x equals 2x, and g prime of x equals 1, because the derivative of this is 1 and the derivative of this is 0. Okay. So now we're going to plug it into our formula. So I'm just going to write that up here. D over dx of f of g of x equals f prime of g of x times g prime of x. Okay, so we're just going to plug this in. So f prime of x is 2x, but we're not going to plug in x. We're going to plug in g of x, which is x plus 2. And g prime of x, which is what we need to multiply here, is just 1. So this is equal to 2x plus 2. And if we multiply that out, we'll get 2x plus 4, which, as you can see, that's the same thing here and here. So we're soon going to look at some examples where you can't just multiply it out and simplify, where you'll actually have to use the chain rule. Okay, in this example, again, if you really wanted to, you could simplify this to 2 sine x cosine x. And then you could use the product rule to evaluate this. But we're big kids now, we're going to use the chain rule. So let's look at what our outside and inside functions are. So our outside function is sine of x. And our inside function is 2x. Okay, now let's differentiate. F prime of x is cosine x, and g prime of x is just 2. Okay, now let's plug it into our formula. We have f prime of g of x, so cosine of 2x, times g prime of x, which is just 2. So that's 2 cosine of 2x, and that's our answer. Now, if you were to use the product rule and figure out the answer from this, you would figure out that this is actually the same answer as it is right here. So I'm not going to do that here, but if you want to do that for yourself, just to convince yourself that the chain rule does work, you can do that. Okay, for this example, we will have to use the chain rule, and there's no way that we could actually do it without using the chain rule. So first, since we have this power in the bottom and that looks kind of nasty, I'm going to write it as a power in the top, but negative. Okay, now let's figure out what our outer and inner functions are. So our outer function appears to be x to the negative 2, and our inner function is going to be x squared plus 1. Okay, differentiate f prime of x. We're going to use the power rule. So the power rule is we're going to bring the power to the front, and the power is now going to be negative 2 minus 1, which is negative 3. And for g of x squared plus 1, bring the power to the front, that's 2x, 2 minus 1 is 1, and for 1 it's just 0. Okay, now let's plug in to our formula. So f prime of x is negative 2, x to the negative 3. But instead of x, we have x squared plus 1, which is our inside function g of x. And next we're going to multiply by this is g prime of x. Next we're going to multiply by g prime of x. So when we simplify this, I'm just going to simplify these constants, and I'm going to bring the x squared plus 1 to the negative third power to be a positive power in the denominator. And so that's our answer. So as you can see here, there's no way that we could multiply this out and figure out the derivative without using the chain rule. And that's why the chain rule is so important, because no matter what functions we have composing each other, we can always find the derivative using these simple rules. Okay, this is another example where of course we can't just simplify this, but let's figure out our outer and inside functions. So our outer function is going to be e to the x, and our inside function is going to be sine of x. So f prime of x is just going to be e to the x again, and g prime of x is going to be cosine x. Okay, now let's plug it into our formula. F prime of x, so e to the something, and that something is going to be g of x, which is sine of x. Then we're going to multiply by g prime of x, and that's our answer. So again, not too complicated, but it can be hard to understand what an inner and outer function are, so make sure to pause and take a moment to think about it if you have to, or slow down the video. Remember, whatever pace is best for you is the pace that you should be going at. Okay, final problem here. This is a composite function using ln. So obviously the outer function here is going to be natural log f of x equals ln x. And our inner function is just the inside of that, which is x squared plus 1. Oops. So f prime of x, you should have this memorized. The derivative of ln x is just 1 over x. And g prime of x, well, we did this before, that's just going to be 2x. So now let's plug it into our formula. So f prime of, that's 1 over something, but that something is going to be g of x, which is x squared plus 1, times g prime of x, which is 2x. And I'll just write that as 2x over x squared plus 1. That's our answer. Okay, that was the last example for this video. I hope you found this helpful, and although the chain rule is hard, you'll definitely get around to understanding it, because you can just go step by step and go super slow, and eventually you'll understand it. I hope you found this helpful, and I'll see you in the next video.